Welcome guys, as you might have seen in the previous video, which is about mastering routing protocols. In this video, we'll be talking about one of the IGP dynamic link state protocol, which is OSPF or Open Shortest Path First. So in this video, we'll be giving a brief introduction of OSPF. So without wasting any time, let's get started. So guys, let's come to our slides that I've made for OSPF or Open Shortest Path First. So let's start. It is an Open Shortest Path First protocol. It is an IGP dynamic link state protocol. It is a protocol that have been designed by IETF or Internet Engineering Task Force. It is an open standard protocol that it means that it is supported by all networking devices. So the OSPF administrative distance is what? 110. You might ask yourself that what is administrative distance? It's a numeric value that gives the routing protocol its trustworthiness. The lower the, what do we call that? The lower the administrative distance is, the better the routing protocol is, or the faster and reliable it is. Like OSPF administrative distance is 110. So let me explain it for you guys in the whiteboard. So in here, as you can see that I have made little topology. So in here we have three routers. One way is configured as what? This way is configured as OSPF, and this way is configured as what? EIGRP. You might ask yourself that it will select what? OSPF as the best path, but it is not how the routers think. The routers will look at the administrative distance of the routing protocols. Like EIGRP have a lower administrative distance, which is what? 98. Even though the OSPF have lower hop counts, the R1 will still select the R2 as the best path, even though it is one hop away from it. So what we have learned right now, the administrative distance shows the trustworthiness of a routing protocol. So OSPF use IP protocol number 89 to transport its packet from location A to location B. So what does it mean by that? It directly encapsulates its packet into its layer 3 or into its IP packet without using any transport layer protocols like we have TCP or UDP. It does not use TCP or UDP to transport its packet from location A to location B. It directly encapsulates packet into the IP. So let's keep going. So OSPF have three tables: routing table, topology table, and neighbor table. It use an algorithm known as Dijkstra Shortest Path First. This protocol, this algorithm. So how the Dijkstra Shortest Path First work? So when we run the OSPF, let's take the pen. When we run the OSPF on what? A router. It will create a what? A topology table. Topology, let's make it like that. It will create a what? Topology table. After creating the topology table, so in the topology table, all the routes that we have in an area, I will explain the area in the next session for you. So it will save all the routes in the topology table. After that, it will take the neighbor. I will just assign the word into it. It will just take out the neighbors into what? Put it into the neighbor table. After it take out the neighbors into the neighbor table, it will then take out the best path and put it in what? In the routing table. So all the primary routes that we have, it will be in what? Or the best route we have, it will be in routing table, and the backup route will be in what? In the topology table. So that's how it works. So OSPF use metric to calculate the best path and to find the best path. So it use what? Cost. So let me explain how the cost work. So the lower the cost is, the better the path. So we have two way in here, the path 1 and the path 2. The first path have 1, 2, 3. Three links, and each link cost is 10, 10, 10, and that become what? 30. The cost will become what? 30. And the second path that we have in here, it have the cost of what? 20. So which one would you think that the OSPF will select as the best path? So OSPF will select the second path as what? As the best path. Because of what? Because it have a lower cost. If you want to calculate the cost, you can find the table on the internet, or I will just show it to you in here. So as you can see it in here that if the speed of the link is 128 KB, the cost is what? OSPF cost is 781. If the bandwidth is 384, it is 266, and it will go on. Like in here we have 10 MB, the cost will become what? 10. So you might ask yourself that how OSPF calculate its cost. So it uses a formula of 100 divided by bandwidth. So whatever link that you want to find the cost of it, you have to just divide what? 100 by what? The bandwidth of it. Like in here we have the link speed is what? 10 MB. So let's just open the calculator and just divide 100. What is the speed of the link? 10. So we'll divide it and it will give us the cost. So what is the cost right now in here? The cost is 10. That's how we calculate the OSPF cost. So let's keep going. OSPF do what? OSPF have something known as equal cost load balancing. So equal cost load balancing. If we have parts like this, that in here we have, I'll just write for you guys. So delete this. So like we have one router, 2, 3, and we have another way is the same, and we have another router which is the same. It's connected like this, this, and this. So when the R1 want to send packet to what, or let's name it 5. So all the ways what? All the ways are what? Equal. Like in here we have all the speed of the links are what? Like 10 MB, 10, 10, 10, 10, and 10. So all the way have the same cost, and they have that. I'll explain it in another video. The other thing that we can also use as what? To how to find the best path. So, or to select a path as the best path. So all the links are what? Equal. So when we want to, OSPF have something known as equal cost load balancing. So it will equally load balance the traffic on all the links. Like in here we have 3 links. It will load balance all the traffic that we have from here. It will load balance it all on these 3 links. It won't use just one link. Right, it will use the whole 3 link. Also R5 if it want to send packets to R1. And when we want to load balance our traffic, that by default it is selected as what? As 4. By default it is 4. But if we want to change it, we can change it to 2. I think it is 8. We can change it up to 8 links or 12 links. I didn't remember it. I will just see it and look for it. So OSPF when it want to send packet, the hello is 10 and the date is 14 second. 40 second. What does it mean by 10 second? When it sends its packet from location A to location B, so it will like what we can say, it will normally after 10 seconds it will send a hello message to see what if the neighbor is alive or dead. So if the neighbor don't give response after 40 seconds, like in here we have, so it will what? Kill the neighbor or delete it from its routing table. So we have for the NBMA, or like we have the one, like if we have connection like this, one router, and it is connected to what? Internet and another router. So for one connection, it use this hello and death timers. Like for one connection, it use 30 second and 120 second for NBMA network. Like after each 30 second, it will check on what? Our neighbor. After 120 second, if the neighbor didn't reply to us, it will just kill the what? The neighbor. Let's come to the multicast. OSPF multicast to 200.0.0.5 and 200.0.0.6 that I will explain it in the next video, which 200.0.0.5 is to all networks and 224.0.0.6 is for the 224.0.0.6 is for what? The DR and BDR. I will explain DR, or we have designated router and backup designated router. I will explain in the next video for you guys, but still, so it will send updates using what? 224.0.0.5 and 224.0.0.6 that I will explain it in the next video for you guys. How does it work? So OSPF has a header known as drone fragment. So what does it do? So by default, the MTU or maximum transmission unit that a router can send is what? Like in here we have 15-bit, 1500-bit. So if the packet size get bigger, like we have 15, 18-bit, it have got bigger. So the router will discard the packet by default. But we have configured what? OSPF. So OSPF has a header known as drone fragment. If the second router that we are sending it to it have not manually configured this interface that the MTU is what? 1500. If it is configured manually that is 1500-bit, it will discard the what? The packet. It will discard what? The packet. But if it is not configured manually that this interface receive 1500-bit to itself, that it is normal OSPF. It will what? Not fragment this packet, and it will what? Send it to the next router. That was a brief introduction about OSPF or Open Shortest Path First. So thank you guys for joining us on this session. See you until the next time. Bye bye.